Hello guys, this is second experiment of the uh, multi-lab, and here we are imported the required libraries, and here we are loaded the data set, and we have got the data frame. Then we are dropping the chlorides and free sulfur columns using drop function, and we are getting the first five values. So we used head function, and we are identifying the numerical columns with outliers, and dropping the columns and the display space to detect the outlier in a column. Using the constraint of 0.25 and 0.75, IQR is equal to Q3 minus Q1. Q1 minus 1.5 into IQR is R. Different temperature data frame column is greater than Q3 plus 1.5 into IQR dot any dot append column. Yeah, here it's the outputs are shown before and after, and here it's we are identifying the numerical columns with variance less than 0.5 and displaying it, and drop the columns with variance less than 0.5 and display the size use. Here the numbers and lambdas are less than 0.5. So before data frame shape and after data frame shapes are shown. Yeah, identifying the input of the column with less than 0.1 correlation with the target column quality and display, and we are displaying it. We have correlation data frame. In the correlation should be less than 0.1, and correlation should be not indices should not equal to quality. Input columns with correlation is less than 0.1, and we are showing the low correlation columns. Next, we are dropping the columns with less than 0.1 correlation and display the size. Here we are dropping the columns with less than 0.1 and dropping the columns. We identify the pair of highly correlated input features. Its correlation is greater than 65%, except target column quality. So C1, C2, C1 correlation dot LOC. If correlation dot LOC C1, C2 is greater than 0.65. So highly correlated input feature values as greater than 65%. After that, we are dropping one feature from the highly correlated feature pair based on its correlation with target feature quality. For iron range, len correlation f dot columns before and after columns are shown. Then separate the input features and target feature from the data frame. Fixed acidity, volatile acidity, citrus acid, and every acids are shown, and the data frames are shown. Estimate the mutual information score of the input feature of the target variable quality, and display the input feature having the highest mutual information. The mutual informations and the MI scores are calculated and given in the series. Then perform a feature extraction using PCA, a step-by-step Python code. Take the first two principal components. We are not using scikit in here. We are using MPA dot data frame and eigenvalues with mathematical values. Not using scikit here. So using argument sort and dot data frame. We are finding out the values of this one, and perform a feature extraction using LD using scikit-learn library. Then we are printing a value, and we are getting the uh, feature vector length. Extract the pixel by pixel with the feature vector length, and extracting the picture using this, and the picture is uploaded there. Thank you.